Hello everyone. In this video, we are going to relate the life annuities under different modes of payments. More specifically, we are going to use the present value of the annuities under the annual payments mode to approximate the annuities with monthly payments or the continuous payment. Here, we will use the UDD assumption. In exam FAM, you are given the life table and the entries only applies to integral ages. And therefore, if you encounter a problem asking you to get the present value or related quantities about the monthly annuity due or monthly annuity immediate or the continuous annuity, you may need the approximation to do the problem. Under UDD assumption, recall in the insurance section, we have the relationship that the present value of the monthly insurance under UDD, this equals I over IM. IM is the nominal rate of interest payable M times a year, and then times the present value of the whole life insurance, AX. Similar for A by X, the continuous case. Apply this relationship to annuities. We have here monthly annuity due. Using the YZ relationship, and then the continuous annuity, and then use these two expressions to replace AXM and A by X, and we get the relationship under UDD. All right, express this in terms of the annuities. Replace AX with the expression 1 minus D times A double dot X, and then multiply IM to both the numerator and the denominator. Simplify the expression, and then we are going to isolate this expression into two terms. And we get a function times A double dot X minus another function. The first function, ID over IM times DM, we denote it as alpha M, and then the second function, we denote as beta M. There's no need to memorize these expressions. This is given in the table in exam FAM under the section interest functions. All right, this is for the discrete case. For the continuous case, we have similar relationship. We simply replace M with infinity. As M approach infinity, the nominal rate, IM and DM approach delta. And therefore, we have alpha infinity equals ID over delta square, and beta infinity equals I minus delta over delta square. And we get the expression for A by X under the UDD assumption. If the interest rate is at 5%, then you can get the value for alpha M and beta M from the table provided in exam FAM. All right, for the N-year temporary annuity due, this equals to this expression. And then we are going to apply this relationship to the monthly payment A double dot X and A double dot X plus N. Okay, so A double dot X monthly payment, we have this expression. And then we are going to apply this to A double dot X plus N. isolate the terms with Arthur M, we get the first term. And then the remaining terms corresponds to beta M. And this expression here corresponds to A double dot X colon angle N, the annual payment. And we get the result. For deferred annuity due, similar logic applies this relationship to A double dot X plus N. And we get this. You can see the similarity among these three expressions. First, we have the A double dot X appears again in the relationship for the every case, for the annual case here. And then for the N-year annuity due, the every case and the annual case. Similar for the deferred annuity due. And then the other difference is the last term related to beta M. For life annuity due, we simply have beta M. For the N-year temporary annuity due, the beta M is multiplied by the expression 1 minus NEX. And then for the deferred annuity due, the term beta M is multiplied by NEX. All right, let's move on to continuous annuity. We have A bar X equals to this expression. And then the N-year continuous annuity. Similar setting, we simply replace the M with infinity for the annuity due, and here for the continuous annuity. And then we have the expression for the N-year deferred continuous annuity. Replace the M here with infinity. And here we get the relationship under UDD assumption. Let's take a look at an illustration. Mortality follows the standard ultimate life table. Assume the interest rate is 5%, and deaths are uniformly distributed over each year of age. Calculate the monthly payment, M equals 12, A double dot 65. All right, make sure that the interest rate is at 5% in order to make use of these tables. We have the relationship Arthur M times A double dot X minus beta M. This corresponds to the every annuity due. So we need to get this expression, this notation. So we have M equals 12 and X is 65. All right, we need to get A double dot 65. From the table, we get 13.5498. And then we need to get the value for alpha 12 and beta 12. Alpha 12, 1.0002, and beta 12 is 0.46651. Do the substitution, and then upon calculation, we get the answer. Or else, we can use the YZ relationship, and that applies the UDD assumption to the insurance. From the table, we can get A65, 0.35477, and then I over I12, 1.02271, and the nominal rate of discount payable 12 times a year, D12, 0.04869. And we get this result. They should be the same, okay, but due to roundings, okay, and there's some discrepancy. Okay, let's take a look at the next example. Given the life table and assume UDD, and then you are given 5 quantities, A.22, A.28, the interest rate 6%, and then alpha 2 and beta 2. Calculate 6 bar, A.22, and then bracket 2. 6-year deferred annuity deal, payable 2 times a year at age 22. Make use of this relationship to get the A double dot x plus n and apply the UDD assumption, and then we get the expression involving alpha m and beta m. All right, so we need to get the quantities 6E22, alpha 2, beta 2, A double dot 28 are given. The pure endowment, nu to the power 6 times 6p22 and 6p22, make use of the life table. This equals L28 over L22. We get the two numbers. Nu to the power 6, the interest rate is 0.06, and then alpha 2, beta 2, A double dot 28. Upon calculation, we get the answer 9.0815. Another example. Deaths are uniformly distributed over each year of age. The present value for an N-year term insurance, 0.05266. The pure endowment, NEX, 0.46112. Given the rate of discount, alpha 4 and beta 4. And we want to calculate this quantity. This is an annuity immediate. All right, apply the approximation under UDD. We have this. Using the YZ relationship, the N-year annuity due, okay, we get 1 minus, and then the present value for the N-year endowment insurance, and over D, the N-year endowment insurance, the big A notation here, this equals to the present value of the N-year term insurance plus NEX. And we get the N-year annuity due, the present value, 7.2864. We get alpha 4, beta 4, and NEX. And upon calculation, we get 7.081. And this is for the annuity due. We need to get the quantity for the annuity immediate. Using the relationship between the annuity due and annuity immediate, with M equals 4. The first term is calculated, and then 1 over 4 for the second term, the last term, 1 over 4 times NEX. The NEX is also given. And upon calculation, we get the answer, 6.9464. All right, that's it for today's video. Thank you for watching and see you in the next video.